to get more clearer and better understanding. Okay then. Okay, are you ready now? Can we proceed? Can I?
Prof.
Okay. Yep. Okay, today we're gonna learn on the topic of convolutional neural network. So, it is a family of neural network as well. We put another word convolutional at the beginning of the word neural network. This one pretty straightforward, basically, the process of convolutional. The convolutional here basically so the difference between the previous class is the word convolutional. Okay, so this meant basically for computer vision. Okay, so computer vision basically means, as I told you earlier, is what humans see, what we see. So we got a vision there. Okay, so vision basically mean what we see. It's different from what we read. Okay, so basically it involves your eyes, what you see, and basically is a picture, photo, video, and so on. So when we have photo, image, video, we normally use convolutional to understand the photo. So convolutional here mean basically is for computer vision. Okay, so data is images and videos. Okay, and all right, this basically the how the brain perceive. So this basically how brain perceive an image. So have an image here. Basically, this is the series of our eyes and how the component of the brain perceive the information here, bit by bit and by component. You know, V1, V4, V5, and all those things. Where does it? So if you look at here, V2. So the process basically, this is a stimulus. We can say it's stimulus. When people see is some of encoding and then happen to the neuron and then understanding what is the things, what is in the picture. So this is what brain happening in brain according to the component part of the brain. So basically, so this is image. So this is computer vision, what you see. So basically in brain, basically something like that. Okay. So in other words, we try to imitate each process of the brain into neural network modeling, convolutional neural network modeling. So this one basically is C and N. Okay. convolutional neural network. All right. So this is convolutional neural network. Okay, and this is where the brain, as we perceive inside the brain, and we try to model it through computational using the convolutional neural network. So these all the process are convolutional neural network basically to imitate the way brains works in receiving, seeing the video in order to understand what is this all about. So when we see this, this is the face of person, and don't know what her names, but we understand this is a person, ladies, and so on. So this is the model that we're gonna learn today, the CNN, convolutional neural network. So CNN is the short form, convolutional neural network, and this image, so mean it computer vision, image or video. So if the image is contain writing, it's also images. Okay, as long it's images, then it's computer vision, we can use CNN. All right, and as I said, so this is a convolutional process, and this is a neural network. When we said neural network, this one, when we said neural network, basically it reflects to our previous lecture. Okay, our previous lecture, modeling the neuron, propagation, target value, input, layer, nodes, weight, bias. So involved in this one of our previous lecture. And today, this is a new thing. We're going to add up one component here called convolutional at the beginning before entering neural network. Okay, so this is the new thing for us. All right, let's see. Okay, so remember this, neural network, convolutional process, and neural network. So we got two names here. So in the end, we have convolutional neural network. Okay. So remember the word convolutional, then adding to the neural network at the beginning. Okay. So we have like this. Okay. So we have convolutional here. Okay. We have convolutional at the beginning. And this is the neural network. So what we learned in the previous lecture. So basically neural network also can be said as fully neural network connected layer. Fully neural network, so mean it is a list of layer from the beginning, input toward the end, the target value and the output. So we call it fully neural network connected. So basically this is a neural network. And the whole thing basically it is a convolutional. Convolutional plus we put another ReLU component and pooling component. So we got four basically. Convolution, in this case happen convolution to the image, then goes another process called ReLU. Okay, then go another process pooling, then we input the output of pooling into neural network, fully connected one. All right, and so this, as you see, this is consists of layer 1, layer 2, layer 2, layer 3, and so on. This is the output layer, and the output from convolutional become the input. The output here become the input to the first layer. So this is first layer, so on until to the output layer. And you see here, car, truck, van, and so on. This is called label. Remember last time? Label. So how many label? 1, 2, 3, and so on until bicycle. So when you see this case, it means that it is object recognition or vehicle vehicle recognition. We try to identify, given a picture, the system be able to say a car, truck, van, and so on. So this is our previous lecture. Label, layer N until the first input and first layer. The input here basically, first we have an image, we do some convolutional before we input to the first layer. Okay, remember we got one convolution, ReLU, pooling, and this is already we learned in the previous. Today we learn one convolutional, ReLU, and pooling. Alright, so this is another perception about CNN, okay? So this basically is convolutional, this part, okay? This part is convolutional basically, okay? So here you got, basically the importance of convolutional is feature learning. We're gonna learning the feature of inside there. Feature is like, if you remember previous lecture, features is what's that information that represent the picture. Okay, if you remember our previous one, the loan bank, the feature is the age, married, existing loan, families, and so on. So in this case, the feature will be the pixel, will come up later. Okay, so they're gonna learning. So the word learning the features. So basically, these are learning the features. Then the features gonna move to neural network. So this is the neural network. Okay, to do the classification. Classification is one of the type of supervised learning in which we're gonna classify either car, truck, van, and so on. So in this case, the important is convolutional, this part, which is the purpose is learning the features. Okay, learning the features, extracting the features also can. Okay, all right. So in this one has convolution, ReLU, and pooling. So we got three things to learn today. Okay, now we move one by one. What does it mean by convolution? Convolute. Okay, what does it mean basically? Okay, okay, so far everyone, anything you want to know? So Ifa, not yet. What does it? I can't remember. Or not yet. All right. Okay, let's move. Let's move. Okay, now convolution. Let's go for the first one. Convolution. What does it mean basically? All right, convolution. So convolution mean basically it is analyzing the image using a filter and to see what are the content. All right, let's look on this definition a bit. So we have the mask shown on the right. So this is the mask. Mask topeng. We also call filter. Okay, and this is the image or the target one. So the mask shown in the right, and this is the image contain pixel. Okay, so we have 1, 2, 3, 4, 5 element. It's a, you can also say it is a metric. Metric is easy way to look at this. Okay. Hope you recall the word metric. Okay. So this is also a metric in some sort. Okay. So we see image everything in a metric. So when we say in a metric, basically it is easy for mathematical calculation. We transform everything, image into metric. Whatever it is, we turn into numbers, metric. So when we have metric, it's easy for us to do some operation on that thing. All right, so the mask shown on the right is centered at the pixel Z5. So basically, if you this look 1, 2, 3, 1, 2, 3, 3 by 3. So basically, we're gonna look output in the center here, 3 by 3. Okay, so this one basically so this 3 by 3 are put at the center. Is centered at pixel Z5 here. So here gonna be overlapping with this position W5 and Z5 are overlapping to each other on top of it. So X5 will be on top of it. So it is overlapping. Okay, on top of this one. Okay. So what you're gonna do is basically do some calculation between this is B filter and this is the A. Okay, so this is B. So on top of it, okay, you're gonna do some calculation between B and A. So Z1 will be overlapping with W1. Z4 will be overlapping with W4. W7 will be on top of Z7. What you're gonna do is, okay, look at this 1 to 9. WI multiply by ZI. So basically, Z1 multiply to W1 plus, okay, this is a summation here, plus Z4 multiply to W4 plus Z7 multiply to W7 plus Z2 multiply by W2 plus Z5 multiply by W5 plus Z8 multiply to W8 plus Z3 multiplied to W3 plus Z6 multiplied to W6 plus Z9 multiplied to W9. So you got there, okay? Then the value of that will be here, okay? Only this part, okay? So let's look on this, okay? Remember? So the value of the summation like this will be the old values Z5 will be replaced by Z5, this one, apostrophe. So this gonna be put it there. Update, replacing the Z5 here. So Z apostrophe 5 will be replacing the original value Z5. Okay, so this is called mask filter. You're gonna move around. Okay, so now this is basic convolutional sum. This is the basics. So what happened here basically is you're gonna move the filter around so that you can update all the value here. So in this case, we got example here, we got filter 3 by 3. So this is the value of the filter 0, 1, 1, 0, 1, 0, and so on. So this is 3 by 3. Okay, 3 by 3. 3 by 3 filter. We call it filter or mask. Shade filter, okay, or mask. Either one. So this is the image. Image of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 by 5 metric. This is 3 by 3 metric. So what happened is this filter will be put there, overlapping. So this one, we have a value filter, specific value. So this is specific value. And then put it on top of this. Alright? So when you top on this, you say 1 multiplied by 1, 1 plus 1 multiplied by 0, 0. 1 multiplied by 1, 1. So plus become 2. So here 0 plus 1 and 1, 3, 0. And then 0, 0, 1, 4. It become 4. So, hold on. Okay. It's supposed to be. Okay, now 4. So this value basically, this one. In the middle, Z5, okay? Z5. So this one, they basically will transform into 4. How does it 4? It is this one. 1 kali 1, 1. Campur 1 multiplied by 0, 0. 1 multiplied by 1 plus 1 plus 0 multiplied by 0, 0. 1 multiplied by 1 is 1 plus 1 plus 0 multiplied by 1, 0. 1 multiplied by 0, 0. 0 multiplied by 0, 0. And 1 multiplied by 1, 1 plus 1. Okay, so we sum this one. This sum basically mean this one. From 1 to 9. From 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this is 3 by 3. If you put 5 by 5, it become 15. So W1, Wi is this one. Xi is this one. So you're going to sum 1, 2, 3, 4. So it is become 4. Okay. So the value here will be changed, replaced by 4, because this is equal to 4. Okay. Then basically after this, you just move. Do the same. Then 1 plus 1 multiplied by 1 is 1, plus, because this is summation, 0, 1, 1 plus 0 means 0 nothing, 1, 0 multiplied by 1 is 0. So you got 0 here, 0, 0, 1. 1 in the middle, 1, 1. Okay. Plus 0, omit, it becomes 0. 1, this is 0, so becomes 0. This is 0, no need, this is 1, multiplied by 1, 1. So it basically, it is 3. So value here in the middle will be replacing to 3. Okay. So here, the value here at the beginning become 4. Okay, easy. Alright, boleh ya? Can everyone can follow?
Prof,
Yep.
does the filter need to always be 3 times 3 matrix?
No need. It is example.
Okay, so
You can have 3 by 3, 5 by 5, 6 by 6, 7 by 7, but basically it's smaller than the image. Okay?
okay,
Smaller than the image.
all right. Okay, thank you.
Okay, so basically, if you look at here, okay, just then move on. So you're gonna, tadi di sini, move to the next, and then we have to move the next again. Do the same. 1 multiply 1, 1, plus 0, 0, and so on. So the process 0, 1, 0, 0 dengan 1, 0, 1 dengan 1 ada 1. Okay. Ni 0 tak, we don't have to consider, become 0. 1, and there 1. So become plus 1. And 0, omit, 1 and 1 become 1. So basically 1, 2, 3, 4. Okay. So this value will be replacing to 4. Okay. So basically it is, ni ada luar ada macam ni lagi sepatutnya. Okay. Remember? Because dia kat sini. Okay. So these are basically this. Okay. So the size becomes smaller a bit after you do the filter. So basically yang ni kita buang lah. Okay. But here, I want you to know the concept of convolutional. So when I said convolutional, you can imagine it is moving. You can imagine this one is moving, and the size will become smaller. Okay, that's the definition of convolution. I want you to remember. So the detail, this I'm talking in detail about what's happening when the filter on top of this, and so this basically when we do some implementation. Okay, when we do some implementation, we do programming, so we want to make it happen computerized, a software. So we need, when we need to develop a software, we need to know the detail, so at least we can have a function. When you use the function, it's going to produce like this. Okay, but basically the important now is the concept of moving. Okay, you see the moving. and so on. They are moving. So as you can see here, the yellow one at the beginning, then move to the next, and then move to the next, and then it will move to the next. Basically, it will move next to next until the end. Okay, so if you look this, so this, then he move here to fill this part, then it move here to fill this part, then it move here again to fill this part, and it move again there to filling this part number, then it move to this to fill this part, and at the end of the day, the last one, you're gonna move this one within this one. Okay, so now the number now different a bit. So this is convolutional. So what you see in convolutional, this is a filter. The size can be any, and the number inside there also can be any number, not necessary 101010101, not necessary by any number, but you have to do the experimenting things why this number are put like this. There must be a purpose, and we'll see later. And if you see this, what it did is basically the image is being filtered. They do some convolutional summation here, and they conclude with one number. And if you look at here, this time this, so overlapping, and it is a convolutional. So you can do other, not necessary summation here. You can do other, you can say just the average of all the thing, but here we just stick with this one, summation, okay? And we stick with this one, summation, okay? So now it moved until the end. So now you see what you notice here, the size, this is the input. This is the input. Then this is the output. So this is filter. So the input 1, 2, 3, 4, 5 by 5, and the output is become 3 by 3, smaller than this one. So just remember, input 5 by 5, filter is 3 by 3. So the output become 3 by 3, smaller. The size is smaller than this. So therefore, now this one, you have noticed that what is the summation, what is convolution. Basically, convolution is the summation of the filter and the input. So you're going to replace the number here. And another one you observe is the output is a bit smaller than the input. The input 5 by 5, the output become 3 by 3. And also you're going to notice what's happening is it is overlapping, and summation product is done there. Some sort of operation. They just take one pixel. They multiply, overlapping then, and then the summation here. So by experiment, this is good in averaging this one. Okay, we'll see that later. All right. So as you can see now, we have images. This is what we have last time. So basically in computer, they're understanding like this. Okay, this is the number. 08 is represent green and so on. This is the number inside there. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you got 20 column and 20 row. Okay, So this is 20 by 20. So this is regarding, so if you, the size will be 400 then. If you say this is 1 bit, so 400 bit. Your handphone is how many megapixel? Camera? So the quality of your camera on your handphone, people say megapixel. The camera is quality with 1.2 megapixel. So here is just bit. So 1 mega equal to 1000 bit. Okay, just basically, just roughly, just to understand you. So if it is 1 bit, so that mean that it is 400 bit per pixel. 400 bit images. Okay, so this is what I mean 20 by 20. So basically, it contains number here. So number here represent the color. So 63, it is represent color brown. Okay, maybe is you have to look at the table. What is 63 is represent for. 36, it maybe represent white. Okay, and so on. So basically, the dog here we're gonna be somewhere like this. If you just hold on, just to understand you this image. Okay. No. Okay. Just hold on. Just hold on. I just want you to. Okay. Uh, okay. Get back to here. So basically, like that. Okay. So this number here represent green. This number here green, green, green. So this, hold on, back. Okay. Just understanding the pen. Okay, pen. So this is green. Okay. If I throw this one, so if I throw this one and there, so basically these are green. So 71, 51, 67, this is also green. Okay, represent this one. Okay, the same thing. All right, so that's one. Then basically what happened is basically you have filter 3 by 3. Okay, 3 by 3. Three by three, and then it move, and here you got 20 by 20, mean 400 altogether pixel. So this is 3 by 3. So this you have to move around next to it, next until the end of the day, until here. All right. The original image basically gonna be this one. The size will be smaller. The original image will be smaller than this one. Okay. Got it? So these are basically just to show you, uh, convolutional. Okay. All right. And okay, everyone, get it? Huh? Okay. Now we just move like this. Okay, just move like that. Okay. It move until the end. Okay, the blue one move, and you have to update down there. Okay, you need to move update here. So this is at here. So this number with this number now 25 negative now become, because you got negative there. It doesn't matter what, as long whatever the summation, you just put it there. Then the blue one, the filter move to the next and take this number and replace by 466 and move to the next. Next in the middle is 163. After you do some summation product, then you just replace by 466. At the end of the day, what you got, you're gonna change this number basically. Okay. All right. Change this number basically. All right. So that's convolutional. You got filter, input, and do some convolutional summation. All right. So this is just basically to show you, you got 32 image, 32 by 32, and you got 5 by 5. Here is 5 by 5. Filter, do some convolutional, you got 28 by 28, okay? A bit smaller than 32. So filter is 5 by 5. The original image is 32 by 32. Then you got the output is 28 by 28. Okay, so these are moving around all in all the area of the image. All right, so you got one image and one filter. If you got six filter, each we're gonna do to the image. The first filter gonna do, so each filter will contain different numbers. Each filter will contain different value in the metric. So we're gonna have six separate things. It's just to say that you can do anything. So if you got six filter, then you have six different number. You change the image, the original, into six different things. Okay. Okay. So this is why you need convolutional basically. So this is the original image. Where you do this filter, okay, it become black. When you do this filter, it become like this. When you do this filter, you only got the border of the head. If you do this filter, the picture gonna be more sharp. If you use this filter, it's gonna be blur a bit. If you do this filter, you are adding Gaussian in your image. So these filter are meant for clearing the thing. This filter with value 0, 1, 0, negative 1, 0, 0. How do I get this? Someone has do research and experiment. They got this number and they prove this number are meant for something. For age detection. So for age detection, you need 3 filter. At the end of the day, you got age. Okay, you got age. So this is considered features, you know. So this is gonna be put it into the neural network so that they can learn. So age are gonna be like this, okay, and so on. Okay. If you got image, you use this 3 filter, you got this. If you have image, you use this filter, and then you got Gaussian. So if your image EEG, you want to put a Gaussian noise, just use this filter. Okay. All right. So far, we're gonna break a bit, 3 minutes or 5 minutes for you to absorb this. But the main important is this is important. Why we need convolutional, and convolutional is just on top of it, moving to each other.